today we're participating in Yandex Cup. It starts in 7 seconds. And we will have 2 hours to solve some problems. Why are you talking in terms of rolling balls? I think it is a poor way to explain this. So is it possible to reflect a piece? Blocks with the left turn can become blocks with the right turn, and they can't overlap with each other. This means that the number of such blocks should be at exactly 6, and number of such blocks should be even, I guess. Okay, I think we can just write it here really fast. So we read to be two numbers then we say, so if a%6 is 0 and a equals 6 and b%2 is 0, then we say that answer is true, answer is yes, and we print the correct way. The correct way will be AAA plus b times b half, and all of this times 2. Else print no. Let's check it really fast. So like 6 0. What's wrong? I need to use spaces. Yes, A. 3 is no. 4 is no. Okay. Wrong answer, just 4. I guess... Stop, what? The installation given in the third example is shown in the figure below. No, it is not. It is not. It is AAB, AB, AAB, AB. Am I nuts? Ah, if it is... Sometimes if it is divisible by 3, it's also okay, I guess. Yeah, so if it is at least... So, if it is at least 2, then we can do it. Yeah, so maybe we need to subtract 3. Yeah, I think yes. Let's fix it. It was dumb. So, and b percent 2 is not 1. Just b is not 1. Print yes. So if b percent 2 equals 0, print this. Else, print almost this, but here we need b minus 3. And we need to add 3 b's. So let's add 3 b's. So 1 b is here, 1 b is here, and 1 b is here. Okay, so 6, 2. Yeah, now it's better. Now it's better. It was dumb, but now it should be okay. Good index. We already suck a bit, but still. It happens and it is fine. Why so long? Because many tests? "70 tests. Okay. Takes the sum of the squares of all the numbers that are digit-wise no greater than the given number. So we are given A and B. We need to find the sum of the squares of all numbers that aren't digit-wise larger than the given A. Aren't digit-wise larger is not the same as digit-wise no larger. Okay, whatever. So we have a number in some numeric system. Okay, so we iterate everything here, everything here, everything here, etc., everything here. And we find a square. So sum of y1 square plus 1y plus yi2 plus etc. plus ik, then to the second power. Okay, so it's sum so we just take all possible sums and square them. No. So how can it be found? So if there weren't this square, then I would say that we could just consider them separately. Okay, maybe we can just simplify the expression. So we have sum for all I1, etc. ik, sum of jij squared plus 2 times sum of all j and l ij il. Okay, let's now no, I guess we can put not equals here. Let's then rearrange it. So first of all, we consider j. Then we consider I1, etc. ik, and we say ij squared plus sum of all l not equal to j, ij il. Fine. So let's now rewrite it as this. First of all, we take ij and then we take ij squared times sum of 1 for all I not j plus sum for all sum over l equal to j sum over il. So here I can put ij il times sum of all I not j not l. Great. So these are two separate summands. So let's start with this one. So let's say that for jth coordinate we have numbers from 0 to k, no, not k, let's say, I know, dj. So this is dj sum for all j. Let's start with this one. This is, do I need to sum with some modulus? Yes, with some modulus. dj minus 1, dj 2dj minus 1 over 6. This is the sum of squares. This is the sum of squares. And times this thing, which is product of d u, where u is not j. Okay. Then we take So these are two separate things, I guess. Yeah, this one and this one. These are two separate things. Yeah, they are like independent. Yeah, they are independent. So we have like product of all DUs times sum of pairwise products of dj minus 1 over 2 dj. So sum of pairwise products of such things, which is simply this. Okay, so this is easy to calculate. So I have several numbers. I need to find the sum of pairwise products. Yeah, so like sum of 2 ai aj where I is less than j. This is simply the square of their sum minus the separate squares. Okay, doable. So we don't read the number of tests. Okay, I will replace with this just what I will say solve tests. And solve test will be bool. I read n and k, n and p. We return false. Then we return true. And we print findings of n and p. Okay, we need to print this function findings. It takes a and p. So how do we do that? We firstly construct the array of digits. Construct the array of digits. So VL digits while a d dot push back a percent p and a divides by p. Then we return findings of d. So let's findings of a vector of numbers. So to do it, we start with this thing. And for this one, we need to find we need to find the all prefix and suffix products. Also, I believe I can put here %mod, where mod is this number. Okay, in this case, it is now the ID. Ref product. I is everything except ith number. Yeah, so we need it of size n. One, we say that ref prod I plus 1 is product of ref prod I and di. And the same for suffix products. So we say that suff product of I is product of suff prod I plus 1 and di plus 1. Modulo mod. Okay, I will put just m, where m is this number. Nice. So now we need to calculate this thing. To do that, we would like to find 1/6 to substitute in this formula. So we iterate over all d's and we add them to ans. We say that ans is sum of ans I addend modulo m. How to find the addend? Addend is product of sixth and product of three numbers, which are d minus 1, and 2d minus 1. Great. Well, we have found the sum of these numbers. Then we need to find sum of pairwise products, and for this we need this. Okay, so we need some numbers. Sum of numbers, which is 0. In the end, we will say that ans is difference between ans and the square of sum of numbers. And return it. But then we need to iterate over all these. Yeah, and here I guess we can afford this. So here we need to find some number. We will add it to the sum of numbers. And we will subtract its square from the answer. No, here we need sum. And here we need difference. So how do we find the number? Number is simply a difference of m and 1, d and 1 half. Okay, I believe. Let's delete it. And delete it. And create new ones. Great. It's not particularly correct. Let's see what and why it did. So here D is 1011, which is definitely correct. I think we need to add 1 to it. It's still total nonsense, but it's better. Answer is 3. We need to multiply everything by the product of all numbers. Don't we? Yeah, we need to multiply it by product of all numbers. So here we also need product of ref prod dot back and this number. And here we need to also multiply it by ref prod. still nonsense. 2, 1, 2, 2. Why is it 3? It's really a little number. So sum of numbers should be quite big. Okay, I don't understand. Everything is tiny for some reason. Everything is really tiny. Ah, here maybe. Maybe here I need to multiply by the product of all numbers. So here... I actually need to say that const int d equals di, but also I multiply it by product of pref and sub. A little bit better, but still two little numbers. Why so little numbers? Why is it so small? Add 1. Example. Ah, here I need minus minus, I guess. And start with -1. And -2. Is 0 minus minus I. It's starting to be funny. It's starting to be funny. Ah, I guess I understand. We actually need to multiply everything by... Like, if we have I, we need to multiply it by p to I. Okay. Let's do it. So here we need to find all powers. There is powers I plus 1 is product of powers I and p modulo m. Then we use it. For example, here we multiply it by square of PWI. And we multiply it here. Great, and also we multiply it here. Finally. Finally. Wrong answer, test 3. No? Ivan Safonov is here. We need to speed up a little bit. Neural networks versus artists. Hmm. So we have artist paintings and neural network paintings. And we need to find the cave. This is ugly. This is ugly. You don't write statements like this. This is ugly. Need to find the cave painting by weight. What is that? Okay, fine. We have two arrays. We need to find the kth order statistics in the merged array in logarithmic time. I'm not sure I know how to do it. We have log n plus 3 requests. So we need the kth one. Okay, if we need the minimum one, we just compare these two numbers. Is it guaranteed that something is random? example, how to find the median. Okay, I guess we have two segments. The segment of possible answers here, and the segment of possible answers here. Yeah, so I will try to compare two middle elements. No, we try to compare two elements which might be exactly k. What do I mean by that? What do I mean by that? Is so let's assume that we just have two arrays. We just have two arrays. And we have k. Yeah, let's take exactly kth element here. Or k half. Maybe k half element. So let's take k half element here and k half element here and compare them. So let's assume that this is better, greater. Yeah, this means that we do not need all these elements. And we don't need all these elements because they are too big and they are too small. It is if k is such a strange problem. So again, we have two arrays. We need to find the kth element. Okay, so first of all, if sum of arrays, so let's make it zero indexed. So if it has at least k, if it has at least k plus 2 elements, this means that the minimum is no good. Because we can subtract. So because so what? No. It means that maximum elements is not needed. The maximum element is not needed. We don't need the maximum element. It is too large. Okay, so what else? When don't we need this element? We don't need this element when this is less than k. So if this is less than k, then we don't need this element. Okay, let's do something. Is how to solve test. How to solve test. We read n and k. We subtract 1 from k because we don't like it to be one indexed. And we run the recursive function solve test n k. No, not solve test, but solve nk, and for example, zero n. Yeah. Okay, so let's do it. So we have void solve, which has int n, int k. No, I think we just need int k. Int upper left, upper right, int down left, int down right, int down right. Great. So let's start with simple things. If upper thing, so UR is minimum of UR and UL plus K plus 2. Plus 1. And dr is minimum of dr and dl plus k plus 1. For example, if we want a minimum element, we don't need any more than this. Yeah. What next? Also, if sum of the arrays is less than k in size, then this element is simply not needed. We can remove it and say that minus minus k. Yeah, how it is done. I think we can say that dl is maximum of dl And we can just say that. Let's do it. So if DL, if UL, UR minus UL is less than K, we need to fix something. Int fix equals K minus UR minus UL. X minus UR minus UL. Okay. So K is fixed and lower array is fixed. And the same for the other array. Nice. Okay, now everything is fine. Everything's fine now. Let's now check. So if UR minus UL I think we can immediately say that if UR is at most UL, we need to return okay. We need to report ans.x, ans.y. So here we return 1 and DL plus K. If dr is at most DL, we return 0 and UL plus K. Then we do the fixes. Yeah, then we do the fixes. Let's make the function report. In the function report, we print TP plus 1 and in plus 1 with an exclamation sign. And also we have bool first less than second. How do we do that? We ask about first and second. We read the char and we return that it is equal to less sign. Okay. So now when we have made the fixes, we need some indices with sum of k. We need some indices I and j which are k in sum. So let's assume that ai is less than bj. This means that we won't need any of these numbers. Or we will need them. No, I think this means that we won't need... Yeah, sometimes this is not possible. Sometimes we need k plus 1. Okay, k or k plus 1. Okay, in case of k, this would mean that we eliminate all these numbers and all these numbers. They are not needed. Let's try and do it. So let's compose some numbers with some k. We can take, for example, so we take I equals I don't know, let's try int I equals k half, int j equals k minus I. Let's also take int upper length, upper sum equals ur minus ul, and the lower sum, which is down right minus down left. Then we take these things and we ask if I... So I is definitely less than US. Now we ask, is it true that J is less than DS? So if J is at least DS, okay, in this case we will have some k minus 1. Or minus j. So we either have a sum of k or k minus 1. So the first case is k minus 1. So let's do it. We ask first less than second of ul plus I and dl plus j. So if q1s, then ai is less than bj. Since the sum is equal to k, we need to eliminate these numbers and these numbers. So we say that dl. So first of all, to eliminate some numbers, we need to subtract it from k. K minus equals I minus ul, and ul equals I. Okay, let's eliminate these numbers. To eliminate these numbers, including j or not? Including j, I think. I think including j. We say that dr is j. Else, okay, it is only if I plus j equals k, of course. Okay, otherwise it's simple, but from the other side. So it's j minus dl, dl equals j, and ur equals I. Okay, what if we have I plus j equals k minus 1? Yeah? So in this case, I guess we eliminate these numbers. Why do we eliminate these numbers? Because AI is too small. It's too small because it is less than I minus 1. Then I, these numbers. No, it is smaller than. Why is it too small? Because only numbers which it can be bigger than is these j numbers and these I numbers. So only it can be only bigger than I plus j numbers. But it should be bigger than k numbers if it is k. Yes, so we eliminate more in this case. So this is the thing to eliminate. And dr is j plus 1. Okay, I think we just need to add 1 to j everywhere and to I, or not. I believe so. This is so messy. No, in this case we don't need to use files. Let's see. If, for example, let's assume that we have this and this, and we have 1, 3, 5, and 2, 4, 6. And we ask for the sixth. 3 and 6. So 3, 3. I say that B is bigger and it fails. Ah, I need to return something, of course. Let's do while true. Okay, again, 3, 6. 3, 3. I say that 2 is bigger, and it says 2 and 4 for some reason. No, it's not nice. It's not nice. It shouldn't be it shouldn't be it. Okay, let's keep track. 3, 6. Ah, 3, 6. Still okay. It made these segments smaller, so now they 2, 3 and 2, 3. And we have I and J. Then it asks about 3, 3. I say that first is smaller. In this case, it says that k is 1. And now k is 2. Ah. Get it. I think it should be like this. And same is here, where I need to subtract I from here, add I here, and say dl plus j here, dr ql plus I here, plus minus. Okay, let's try again. So I say less, it says 2, 3. And then let's ask about 3, 6, and now I say greater. Then it again asks about 3, 3. This is stupid. Why is it again asking about 3, 3? Ah, okay. That talks about something simpler. For example, fourth, 6, 3, 5, 3, 1. Again, if I say less, it says 1, 1. And if I ask about, if I say greater than, it says 2, 1. Okay, now 3, 6, and they ask about fifth. No, 3, 5, and I ask about fifth element. 3, 3, I say less. Now it says 3, 2, I say bigger. It says 1, 3. Okay. 3, 4, 2, 3. And I say less. Then it says about 3, 2, and I say bigger. 2, 2, I say less. This says 2, 2. It's fine. 3, 3. 2, 2. I answer less. 2, 1, I answer bigger, bigger. 1, 2. Yes. 2, 1, 2. Say smaller. Say smaller. Say bigger. 2, 1. Okay. Let's also have something like this. I even think I will need to ask about 1, etc. 10, and then 11, etc. 20. 10, 10. So 5, 6, I always say less. 110. Okay, 11. Less. 2, 1. Okay, I believe it might be right. But it can easily get RE, for example. This is unfortunate. I think it already got. No, it's not run timing. It's already on test 10. Okay, maybe problem D? Robot dance. Why are they so fast? Ivan Safonov. Okay, we have a permutation. We need to find max of union of some cycles. Okay, this is an easy problem. We need to find all cycles and we need to find max in Okay, this is hard. We have some queries, we have a segment, and we find a max on a segment. How to find a max on a segment? How to find a max on a segment? We have some array, we have some numbers in it, and we need to find a max in this array. On a segment. We would like to have all the queries in advance. And we can. I guess we can, yes. What is that? I really don't know how to find max on a segment. We have an array with some numbers. Need to find a max. Okay. Assume that we can find max for any suffix of an array. So starting with in some position, we can find a max of any such array. We have like an array of maxes. What if we add a number here? So this number doesn't change a lot. Or does it? So we have some sort of array of increasing array of maxes. So we have a new number b, and it can only intertwine here. Okay, because here max was, if b equals a2, then max only changes here, changes. We need to recalculate it again. And this is hard. It's in rhetorics. Max on a segment. Okay, if my teammates were here, they would say, Misha, it is obvious. It's like taught in El Kasha parallel C prime. And maybe it is taught there, but I don't know. Max on a segment. Max on a segment. So the problem is if we have the left segment of only even numbers and the right segment of only odd numbers, we need to spend linear time to recalculate this max. So it's not like divide and conquer. Instead, it's definitely offline algorithm to do it. Okay, how about removing numbers? So assume that we know all maxes here on every prefix. Yeah. I believe that can be true. So assume that we know max on every prefix. This is easy to do, so we know it. Now let's remove this element, A. So we need the next A. Yeah, and on this part, nothing changes. But on this part, max makes min equals. Yeah. So for each element, we need to find its next occurrence. Okay. Sounds legit. Let's do it. Length of the permutation n. Read n. And if we failed, then return false. Here we return files. We don't need these things. Instead, we need find us. So here we read the permutation. Then we read all queries. Zero indexed. Finally, we find uns. And we print it. So let's find uns given a permutation and queries. So first of all, we need to find all cycles. Let's do it. Let's find all cycles. So we go through all numbers. So if not visited I, then it is a new cycle. I think we can even do this. We can make number of cycle here. We can store it here, and we ask whether num is -1. So if num is -1, then we have a new cycle. We push back it here. We say that num I equals min and cycle dot size. Then we need to go along this cycle. Int j equals pi, while true, while j is not I, we say that num j is also min and cycle dot size, and we go j equals p. Right. So this is decomposition into cycles. So each number now knows its number of cycle, and for each number we know for each cycle we know its minimum number in it. Finally, we need to push back n here. Then we need to answer some queries. So let's consider some queries. Let's make an array of size n. This is actually num. So we have an array num. So we have some worker which takes num and v, and we ask it to find ans. And then finally, for each number in this worker, we replace it with min in cycle I. Great. So structure of worker, how it works. So we store an array. And also we need all the queries. We have time. Quite a bit. So what does worker do? The worker answers some queries. So we have some segment tree, which is capable of min equals on a segment, I think. To make min equals on a segment, I believe. What do we need to make min equals on a segment? If we have an increasing array, a increasing array. So we have some sort of this array. We have two queries, find an element, or even find, yes, find an element, and make min equals on some segment. Well, how can we make min equals on a segment? Or even on a segment on a prefix. Of course, on a prefix. We need to make min equals on a prefix. Okay, I think it is simply a sorted array. Sorted stack. So like we need an array in this direction. Okay, this is doable. This is totally doable. So first of all, we need to sort all queries by their x coordinate. Instead of sorting, we can make a counting sorting. So we have vi queries, for int I equals 0 and v dot size plus I. What do we do here? If queries dot size is at most vi dot x, queries dot resize vi dot x plus 1. Then queries vi dot x dot pushback I. Nice. We have all queries. Now we struct structure which is capable of storing an increasing array and finding min equals. So let's do it like min equals on a prefix, and we store some so it is decreasing. No, it's like a list. It shouldn't be an array. Again, what do I need? I need my min equals on a segment, on a prefix. And the array is increasing. Okay, let's make a simple segment tree. Although a segment tree cannot be simple. It is million here. I don't like the idea of making a segment tree. Ah, it looks like a set, of course. It's a set. So we have a set of, or even a map. Okay, we have a map. Value to its leftmost position. Okay, this structure is called a map. So what does it store? It stores an non-decreasing array, and for each value it stores leftmost position. Yeah? Okay. Oh, sorry. How can we perform this? How can we perform it? Also, let's store. We store additionally infinity -1. No, minus infinity -1. And we store infinity n. Yeah, okay. This is for it to be easier. Okay, so what do? We need to find the minimum element which is greater than val. So let's m dot upper bound of val. Okay, we did it. So this is the last element which is at most val. We don't change it. Now while true, we try the following. Take auto jt equals it plus plus jt. Let's check. Is it true that it is less than p? Yeah. So if jt y is at least p, we don't touch it. We don't need to touch it. Yeah, so we stop. Okay, now let's assume that it is less than p. So we have some segment which has value greater than val. No, yeah, it has no value greater than val. What do? We replace it. So we say int current val equals jt x. Then we say that okay, what we really need to do is okay, so we found this place. We found this first element. Okay, I don't think we need to do it in an infinite cycle. Okay, so if it is at least p, then we do not need to do anything. We return. Let's think what it if it is less than p. In this case, we say int last value equals val. We say that m val equals it y, and while true, now we say it equals m dot lower bound val, while true, we say auto jt equals it and plus plus jt. So if jt x y is less than p, then it should be replaced. We say that last value is jt y x, I meant, and we erase jt. Okay, if it is greater than p, then we okay, else if jt else we break, definitely we break, but before that, if jt y is greater than p, we need to add one more element, which is last value. Okay, now we only have 11 minutes. It's fine. This was the first part. And now we have the second part, which is... Oh no. Actually, we need to make both. We need two separate binary searches. Don't we? This is sad. We need two binary searches. Okay. We can do the same with the second map. We can do it with the second map. Okay, let's try doing it with the second map. Although it is huge pain. This is actually miserable. Hmm. Hmm. Maybe I can do it with a custom comparator. Yeah, I can do it with a custom comparator. Okay. Let's do a lower bound. So we only need it if it x is less than val, then we need to do it. No, if it's greater than val. Otherwise, now we make okay. Now while true, okay, great. Can I have two arguments here? No, I cannot have the second argument. Oh no, you you should be kidding. C++ is officially a bad language. It's bad programming language. It's not programming language at all. Okay, rage quit. So, what I was planning to do here, I need a data structure which is capable of storing a non-decreasing array. Non-decreasing, yes. And it can make min equals on a prefix. So you can give me two numbers p and val, and I can do this for all I less than p. So this can be easily done with a segment tree with lazy propagation. But this will be slow, and I don't want to write it. Instead, I came up with a data structure which is called set. And because sorted set in C++ is capable of storing a sequence of values. Yeah, so let's store only, I want to store pair value position for all values which are occurring the first time in this array. For example, this element will always be here. So, and the unfortunate thing is that I need to find two different comparators for working with these pairs. I need comparator which compares by the first element to find here the first element which is at least a value to replace everything in this set here. But I need the comparator by the second value to find elements. So I need this query, just find AI. And to do it, I need to compare by the second element. And this means that I have to make some separate class which is capable of comparing either by the first coordinate or by the second coordinate. Because, you know, in this set, elements actually are sorted by both comparators. So both in both orders, this set is correct. But still, it doesn't allow to give to give some custom comparator. It just won't work with it. So I have 2 minutes, like in 30 seconds, to make some custom comparator, and I will not, because I hate this problem so much. Okay, but some people like writing such problems. Simply not me. Okay, bye.